Logarithms. Logs. This is a topic that a lot of people that have not done A-level maths or they did A-level chemistry and they were like, what the hell? Why are we taking the anti-log order? Like, this is to clear up basically what they are. They are actually quite a simple, like, mathematical concept, function, whatever. And it is really important that you know what logs are, because they're going to come up all the flipping time in your degree of whatever bioscience you do. So let's clear this up now. Okay, so I'm going to start with a big brain question, because I know you watching this, you have a very big brain. Okay, 10 to the power of what is equal to 100? Now, I know what you're thinking. It's 2. You will be correct, it is 2. Okay, how did you work that out? Well, because I have a small brain, I cannot work that out in my head, so I need to rearrange this equation to make x the subject, and then spell out what it is. Okay? So how do we do that? Well, the answer to that is we use logarithms. I'm going to write the answer out as what it would be if we were to rearrange this using logs. It would be x is equal to log to the base 10 of 100. Let's clear up the definitions here. Let's define, what these are. So this is the base. Okay. And this is what it's raised by, the power. So that the base and the power. Hence why, when we read this, it's log to the base 10 of 100. Pretty simple. Okay, now let's actually have, I guess, more of a realistic case, because I'd imagine that we'd all be able to do that in our head. Say if we had like 2.8 raised to what power is equal to, I don't know, 152.1. That's something that we can't work out, but using the same process that we used over there, we can do log to the base 2.8 of 152.1, and that will equal the answer we're looking for. Now, if we type this into calculator, remember, like, a lot of people get really, like, overwhelmed when they see, like, a number like this. This is like any other number, you know. This log thing right there, like, it's like 1, 2, 3. Just treat it the same. So because of that, let's type this into a calculator. So you'll be able to see your log, like, there'll be a log button on your calculator. So we do log to the base 2.8 of 152.1, and that's going to give us basically 4.88 to 2 decimal places. So that's what we would raise the power by to get 152.1. Pretty straightforward, right? That's basically, like, sort of the way that I think about it. And when I'm doing log questions, at least when I started out, I would always write 10 squared equals 100 and log to the base 10 of 100 equals 2. I'd always write this at the top so I could refer back to this, because you can definitely see the relationship between what a log is and what the base and power are. You can definitely see that relationship is what I'm trying to say. Words. Okay. Cool. Now, there are a few more things that we want to do. There are 4 things that I want to cover, which are basically the log rules. There are the laws of logs, or however you want to call it. And there are basically 4 of them. There's only really 2. 2 of them are pretty easy to remember. You just got to remember, like, 2 of them. It'll be fine. It'll be fine. Don't worry. Okay. So, let's do the first rule. So if we say have log to the base a represents any number, anything can be put there as long as it's a number, of x, y. So this is saying x times by y, and x and y can also be any number, basically. That's the same as saying log to the base a of x plus log to the base a of y. Okay, now vice versa. You may have already guessed this, but if we were to do this, so we were to do a division, so x divided by y, that would be the same thing as saying log a of x minus log a of y. Pretty straightforward, right? Makes sense, you know? Nice. Okay, the third rule now is what's known as the power rule. Now, this thing is very important. It will come up quite a few times, I'd imagine. So the power rule is quite simple. It is basically saying that, let's put x in front of the log. So x times by log of a, of y, log to the base a of y, sorry. Now that's the same thing as saying log to the same base of a, log of the base a of y raised to the x. They're the same thing. So we can actually pull this x and put it inside the logarithm. And it will be y to the power of x. So that's quite useful, and we'll demonstrate that, I guess, later on. Okay, so they're the main rules, and there's one last rule as well, which is basically log of if the base is the same as what you've got inside it, so the thing that you're taking the log of, you'll literally, that will just be 1. So you can do this with, like, I don't know, log to the base 6 of 6 is 1. They're all going to be the same. They're all going to be 1. That's just a rule you got to remember. These are the rules you got to remember. Take a screenshot, write it down, do that. Okay, let's do an example now of using, so we can use this knowledge. We've got a pretty beefy example here. It's going to look quite scary, but don't worry. It's okay. Grab your cushion, stick it up to your face. Whoa, that's not supposed to happen. Okay, and you'll be fine. You'll be absolutely fine. Okay, so we want to solve for x. We want to know what x is, and there's a lot of like just crap, isn't there? Just all in this equation. So we're going to clear this up and try and solve for it using the knowledge that we have learned. Okay, so the first thing we're going to do is we're going to add. We want to get rid of that minus log because who wants minus? No one likes minuses. Go away. Disgusting. Cool. One thing I'm going to explain as well is there isn't a base on this log. If there's not a base on the log, it means log to the base 10. So I'll write this in the corner actually just to let you know. Log to the base of x is equal to, log to the base 10 of x is basically equal to log of x. They're just a shorthand. There's also another shorthand that I'll just explain now. It's something called the natural log. You might see ln x. That's the same thing as saying log to the base e of x. And e, if you don't know what e is, it's like 2.7 something, blah, 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 I don't know what it is. It's an irrational number like pi, but it's just, yeah, it's just a number basically. I'm not going to explain what it is in this video, but anyway, so we're going to get back to this. So we've got 2.6 on this side, 2.65, plus log, remember, to the base 10 of this, because it's now on this side, is equal to log of x over 0.05. Okay. Now, using that rule, you can see that there's a divide here. So we're going to break the log up. So if we do this, see, I don't have any fancy PowerPoint, so I'm just writing this down. Bear with me. Okay. Look at that. Makes sense, right? Just brackets. You can literally, you don't have to put brackets, whatever, if you want to put that. So you can see we've broken this up into 2 logs now, with a minus in between. Okay, so the next thing is we want to get x by itself. So we're going to plus both sides by log 0.05. 0.05. Okay, so then this comes to 2.65 plus log of 3.1 times by 10 to the minus 3 plus log 0.05 equals log of x. Pretty simple. Now we're going to use the addition rule that we learned, and we're going to add these two together. We're going to fuse them Power Ranger style. So we're going to get this. Now we're going to get this of this one times by this one. You can also put another brackets here, but whatever. I like using brackets, just it really really sections the components off and like makes them, you can just definitely see that that's like one thick Chad component in an equation, and you can manipulate that component if you like put brackets. It really shows that, if that makes sense. Does that make sense? I don't know. Anyway, yeah, so that's going to equal to log x. Sorry, this should be not an equal, so this should be a plus, because that is not how an equation works. So that's what we've got so far. Now, let's use our big brain energy, and let's write that thing that I talked about writing earlier. Let's see how this relates. So remember that this log here, log of x, the same thing. Ooh, this is log to the base 10 of x, remember, and this is also log to the base 10. So using this idea here, if we put brackets around this just to like show that this is like one thing, we can actually rewrite this whole equation as 10 to the power of all of this, right? We can rewrite the equation to just like all this nonsense. Now what's great about this is because this doesn't matter if it looks really complicated, because this is all going to be shoved into a calculator anyway. So it doesn't matter. That's the answer. That's what x equals. So now if we type this in to a calculator, be careful with the brackets because I've got 3 sets of brackets here, but you might have 2, whatever. If we work this out, we get an answer of 0.069. So rounded up by 0.07. It's like something continued, but yeah, 0.07. Okay. Now you might be thinking, what the hell? There's no context to this question. What? This is like really useless. Well, what we just solved for is we solved for the conjugate base concentration. This would be in molar, I guess. Using the Henderson-Hasselbalch equation. This will come up in biochemistry. If you Manchester Uni, it will come up in second semester biochemistry. Now, I'm going to talk about the applications of it now because I did mention pH. And if you've done A-level chemistry, you'll know that pH is defined as negative log to the base 10 of the hydrogen ion concentration. Concentration is denoted with the square brackets. And using what I just said earlier, we can rewrite this as log of this. Cool. Okay. Now pH is very useful because it almost acts as like a compressor. That's how I picture it in my head at least. So let's take, I don't know, 2.5 times by 10 to the minus 3. Like this is molar of hydrogen ion concentrations. And let's take 2.5 times 10 to the minus 5, also in molar. Now these numbers, if we were to unstandard form them, we can probably see this difference. This is how we do standard form, by the way. See this? 1 jump, 2 jump, 3 jump, decimal point. Look at that. Just so you know. Because I think there are still some people that struggle with standard form. So 1, 2, 3, 4, 5. Whoa. And then we fill in the zeros underneath the little rainbows. It's pretty cool, right? So basically these two numbers, that is a big difference between these two. That's freaking huge. So because this difference is massive, it's really hard for us to like write this down. Or if we were to graph this, it's going to be so annoying to graph. So what we can do is we can put these into logs and then we can basically shrink that difference. So for example, if we were to logify these answers, so if we were to negative log to the base 10 of 0.0025, we would get an answer of, what do you think it is? It's probably like 2 point something. Can you hear that wind? Whew. My house is going to get blown down. Okay. So this one here is 2.60 basically. And we do the same thing for the other one. I am going to guess like 4 point something maybe. Hopefully. Let's see. Was I correct? Probably not. Not 25. Oh, I was correct. Yay, okay. So that's 4.6. So you can see that like the difference between them is a lot more manageable. A good example of maybe explaining it another way as well. If you were to graph, say you had like you wanted to graph 10, 1,000, and then like a million onto a y-axis here, you know, that freaking axis is going to be like the freaking height of a space elevator kind of thing. So to avoid that from happening, if we were to take the logs of these, so if we do log to the base 10 of 10, we know that that's going to be 1, as mentioned earlier. Log to the base 10 of 1,000 is going to be 3. And log to the base 10 of a million is going to be 6. It's nice and inconvenient because actually these are the amount of zeros in these numbers, so you can actually like, that's a really easy way of doing it for log to the base 10 of those kind of numbers. But anyway, you can see how the difference shrinks, and that is what logs are used for. That they're used to like, they're like the MP3 file of WAV files. If that makes sense. Okay, that may be a bit nuanced. Okay, bonus round. I forgot to actually do this example. I did say earlier that I would show this in an example, but I did not show it. So let's just do this quickly. So let's take pH. Now this is a question that I asked, and I think a lot of other people do as well. Why is there a negative in front of the log? So that's we're gonna be using the power rule to explain why there's a negative. Because usually hydrogen ion concentrations are something times by 10 to a negative power. We can use the power rule, and instead of write this as just negative, we're going to put -1 there in front of it because that's what it's saying. It's saying -1 times by log to the base 10 of this thing here. Strange brackets. So basically what we're going to do is bring this -1 and raise this so that the inside of the log is going to be raised by the -1. And doing so, basically, well, I mean, 2.5 is basically saying 2.5 times by, raised to -1, times by 10 to the -3, times by -1. And basically this makes it a positive, because as you can imagine that 2.5 to the -1, well, that's just going to be 0.4, and then times by 10 to the -3 times by -1, which is going to make this a positive value. So let's just type that in quickly, so we can see how this is done. So that's going to be 1,000, right? Wait, why did I have to like think of that? Yeah, that's literally 1,000. So 0.4 times by 1,000, right? That will be inside the log inside here. So log to the 10 of 0.4 times by 1,000, that's going to equal 2.6-ish, which is the answer that we got already. So hopefully that just clears how we can see the power wall being used in actual application, I guess. That's all I want to explain today. I think I've covered what I want to say. I don't really have a script, but hey, welcome to the School of Biological Science Society. I really hope this made sense. If you've got any questions about all of this, feel free to comment. I will happily answer them, because I know that this is like an area where if you've not done A-level maths, it might be a bit confusing. I hope that I've summed this up and I've not confused you too much. But yeah, so thanks for watching, and stay tuned because we've got some pretty cool content planned.